How is it that a country of endless coastline has never found a commercially viable way of harnessing the continuous energy of its three surrounding oceans? We are Neptune Energy, and we're trying to find the answer to this question. Our team is made up of four Master of Mechanical Engineering students from the University of Melbourne, under the guidance of fluid dynamics expert Jason Monty. We all grew up loving the ocean and are passionate about the renewable energy sector. We are the first engineering team to undertake our capstone project alongside TRAM. This has meant that we've been able to develop both the fundamental technology and a detailed customer analysis at the same time, with the aim of creating a positive project symbiosis. There are two parts of a renewable energy system: harnessing the energy and doing something with that energy, so storing it or directly using it. At the start of the project, we conducted some research and came up with an idea for how we could produce and store energy. The idea used wave energy to pump seawater up a hill to be stored in an upper dam or reservoir. This water could then be run back down into the ocean through a turbine when the energy was needed. This concept is usually called pumped hydro storage, and so in our case, we would be using saltwater pumped hydro storage. In terms of harnessing the energy, the problem that we thought our device solved initially was that it was a simple mechanical system that did not have complex parts that were susceptible to damage in the water. The problem we initially thought we were solving in terms of storage was that normal pumped hydro requires the construction of two places to store the water. In our case, we can use the ocean as the lowest storage reservoir, essentially halving the capital cost of storage. As we discovered though, this initial concept might not have been the most suitable or feasible solution. A lot of people, when you mention wave power, will remind you of all of the failed wave energy projects that have gone ahead in the past. We aim to learn from their mistakes, and as a result, most of the early insights came from people who have attempted projects like this in the past and failed. In some early interviews with experts, we validated some assumptions about our design. We were told that a lot of projects failed because they underestimated the conditions out at sea, and so many of their designs got destroyed. A design that could actually withstand the deep ocean would be very expensive. We were told that if it was possible, we should try and focus on waves close to shore. This was good news for a team focusing on the power of broken waves. This also made us realise that our point of difference could be a simple and cheap design, as opposed to the usual wave power projects, which are complex and expensive. We also talked to some people about our storage solution, a group of experts who rank potential pumped hydro locations for economic feasibility didn't think saltwater pumped hydro was feasible at all. We also spoke to someone from the EPA who explained that we would have to overcome many hurdles and pay for a lot of environmental approvals if we wanted to take seawater in and out of the ocean. We were treating the ocean as a free resource, but really it's far from that. This made us question why we had fixated on just one storage method. It also made us realise that our project was now heading in a completely different direction, and as a result, we needed to pivot. We now have a new focus. By pivoting away from saltwater pumped hydro, we started to consider new energy storage techniques like flow batteries and hydrogen. We also discovered that some customers may benefit by using the power directly, eliminating the need for storage at all. Our idea is still unique. We are harnessing energy from waves that break on the shore, and this has never been done. But we are now changing our design so that we are using the energy we harness from broken waves to provide energy to our customers in the way that they need it. This slide highlights that we can split up our insights into two categories: technology-based and customer-based. This distinction has allowed us to categorise ideas and work through both of these areas in parallel. Listed here in a second are key insights that we found through interviews with a broad range of stakeholders. We know that we can provide energy when solar panels can't, especially at night time when the waves are pumping and the sun isn't shining. We also know that our customer will want an idea of how much power we can produce and the associated capital cost per unit of energy. And we know that coastal communities and councils, who are directly feeling the effects of global warming, want to support green energy projects. As a result of these insights, TRAM has allowed us to narrow our focus to a group of coastally located, small to medium-sized energy users. From here, once we have tested our device and found a reasonable power output range, we will be able to gain a greater understanding of who our technology is suitable for. However, our current understanding is that a small to medium-sized coastal energy user, such as a surf lifesaving club or a coastal council or business, could be a great early adopter. If you know of anyone that would be interested in investing in this kind of technology, or could give us some useful advice, give us a wave. Thank you everyone for listening.